Hi everyone. Today I'll be live solving the second USACO 2020 January bronze contest photo shoot. So first, I'll read the problem and share my thoughts. Okay, so first thing, we have n cows up to 1,000. So 1,000 isn't too big, so we can loop through. Okay, so he wants a specific ordering for his cows. Okay. Now there's a new sequence that's one less than the original and it stores adjacent ones. So it's as if there's a new number for every adjacent number. So between 1 and 2, between 2 and 3, and that number stores the sum of these two. And that's in B. Okay. So you want the minimum A that could have produced B. So the minimum A is such that the first number, or such that all of these are, this is satisfied for all the B's. Okay. Okay. Okay, so since they want the lexicographically minimum permutation, alright, the first thing you want to notice is once you have one number down, you can calculate all the other numbers. So, like using this permutation, right? So, or using this array, b1 to bn minus 1. So let's say you have the first term a1. A, oops, it's not working. Okay, a1, right? And now you have this array b1, b2, and so on, bn minus 1. So you know a1 plus a2 plus a2 equals b1, right? So you would solve for a2 by doing b1 minus a1, right? So this goes a1, b1 minus a1, right? And now to solve the next term, you just do b2 minus a2, which is also this term over here, right? So this term would be b2 minus b1 plus a1, right? And you do the same thing for the rest of it. You just do b whatever minus the last term to get the new term, and then b3 minus this term to get the next term. It would be b2 minus this thing over here, right? So b1 minus a1. And you don't have to redo b1 minus a1. You can just use the last term since you found this already. So basically, what you can do once you have the first term is you just loop through and create the whole array. And yeah. Now the next challenge part is, how do you determine what the first term is? So in this problem, since n is less than 1,000, we can loop through all the numbers from 1 to 1,000. And this way, we will also have the lexicographically minimum permutation, since we start with the first term 1, and then we do first term 2. And we know that, again, for each number, each first term, there's only one sequence that will satisfy the arrays. So therefore, if it starts with 1 and it works, you know that will always be the lexicographically least. So whenever the first time you find a solution, you know it will be lexicographically least because the first term will be the lowest possible value that has worked. Okay, so basically what we do is we loop through all possible A1s. We loop from 1 to n, and for each time we go through the loop, we construct this array. So the possible, or the only possible A1, or the only possible array A given this array B. And yeah, again, oops, oopsie. Alright, so again, move this over. We do this by doing subtracting whatever the first term is, or whatever the term is, or doing this minus this term, this minus that term, and so on. Alright, so now I will, oh yeah, actually, before I show this, before I start creating my solution, um, uh, the way, like after you construct this array, what you want to do is just check whether every number is present, whether every number from 1 to n is present in this array. And if they're, the way you can do that is you can add the numbers to a frequency array. So that array stores a frequency of every single number. And if you loop through the frequency array and every number from 1 to n has frequency 1, you know that it works. And if it ever has frequency 2, obviously it doesn't work, because uh, that means if one of them's 2, another one has to be 0. Um, and yeah, so if all the numbers are present, again, it works, and you print it out. Otherwise, you go to the next A1, and you continue making these arrays. And again, this will run in time because there are 10 cubed values for A1, and once you construct the array and you loop through the frequency list, the maximum n you'll loop through is another n, which is another 10 cubed. So therefore the total runtime will be 10 cubed times 10 cubed, which is 10 to the 6th, and that will run in time. Additionally, you could use a set or a map to store the frequency of these numbers over here once you add them, or once you find what the value is, but that is unnecessary for bronze, so I'll stick with arrays to make it easier. However, you can look those up if you'd like to use them. Alright, so first things first, this is my input, this is my includes all the functions that I need. First we take an input, right? Say n, and then the array b. Alright, so first we'll create an array A. Actually, we can create an array A inside the actual loop, so I'll actually only create an array B. So B will be size n, but just to be safer, I'll make it size 1000, because I may as well make it larger than necessary. Okay, now n. So now I take an input for n, and now I'll take an input. So I loop n minus 1 times, n minus 1, right? Alright, now I take in the values. C in val. I'll do int val. So it's just a dummy variable to take in the input. Actually, I realize I have a B array, so I can just immediately insert it into the array. Yeah, just to make it a little easier, I will one index, which means the first value will go into B1 instead of B0, and then B2, B3, and so on. Okay. And now, after I've done that, we will iterate, like I said, we'll iterate through all the possible A1 values and construct the array. So for it, I equals 1, minimum A1 is 1, and the maximum is n. That's an equal to n. Alright. Now what we'll do here is we will construct the array A. So now we create a new array A. Int array. I'll make a size, I'll just make a size 1000 just to be safe. I'll call it ARR, that's the array name. And we know that the first term equals, what does it equal? It equals I. Right? And now we will loop through to create all, to fill in the array basically. Yeah, to fill in all the spots, all the spaces in the array. So we loop through I equals 2. Oops, sorry, j equals 2. So we start the second term. J is less than equal to n, and we increment j. So now we input the value into array. So array j equals, again, if we go back over here, it equals to b1 minus the previous term to make this term. And then to make this term, we do b2 minus the previous term. And yeah, you can just write that as it will be equal to b j minus 1, right? Because for the second term, you have to use b1, For the third term, use b2. For the fourth term, use b3. So you have to subtract 1 from j, equals b j minus 1, again, minus arr j minus 1. So arr array j minus 1, that would be the previous term here. So again, for the second term, you will subtract the first term. For the third term, you will subtract the second term. So you do j minus 1. Whatever the index is here, subtract 1. And this will fill in the array. And again, we'll create a frequency list of all the values from 1 to n. So this will track how often that the number in that index appears, right? So this is a common idea in bronze, in frequency. So basically, frequency of array j. So whatever that value is, the frequency of that, we have to increment it, we have to set it equal to 1. Okay. Let's see. Actually, since we declare the array inside the loop, it will not automatically be all zeros. So, to fix that issue, what we can do is just, we may as well, we can just loop through every single variable in frequency, and then set it equal to 0. J equals 0, j is set equal to 1000, and we set the values in the frequency list to 0, which means no numbers have occurred. So if, let's say, array of j equals 1, so the first term is 1, right? We will increment the frequency of whatever that number is. So in this case, I would increment the frequency of I by 1, so plus plus. And here, we increment the frequency of whatever array j is by 1. So here, plus plus, right? And now we just, after we've constructed the array here, we loop through the frequency array, j equals 1, j is less than or equal to n, right? We check if every single number from 1 to n is present in the frequency array. So if, let's see, if frequency of j is equal to 0, or we can say not equal to 1, equal to 0, we have to continue. So we don't do anything. We just continue, or break. Sorry, we break out of this loop. And otherwise, if we're on the last term and it's not equal to 0, so if j equals n, right, then we found a solution that works. Frequency of the last term n is not 0, so we went through 1 through n, all of the terms are there, which means we found an answer. And now what we do is we just print out the array. So we loop through array int k equals 1, k is less than or equal to n, increment it, so 1 to n, we print out array of k, and then space in between. Let's check if that works. Okay, after we've printed all of these, we just quit the program with return 0. Okay, let's see. Yep, and we won't need this here because we'll never reach this. Okay, now let's try running a code and debugging it, which is a major part of these bronze problems. Okay, let's see. I will type it in 4 6, and let's see what happens. Okay, my code did save. Fortunately, I expected that, so I copied my code. 5 4 6 7 6. Let's try again. Okay. Close that. Let's see. Okay, so print out 3 1 5 2 4. Which wow, first try. It actually matches the solution there. So now I will try putting it or submitting it into USACO. Right. Wow, usually the code doesn't work on the first try, but in this case it turned out to work. So this one's called photo.cpp. So I'm using an online IDE, so I have to save it like this. But if you use your own IDE, you can immediately directly save it as a C++ file or whatever language you're using. So I'm going to try to submit that one. Let's see. Let's go to computer science. USACO, January, and it's called photo. Okay, submit. Let's see how it goes. Let's see some green, hopefully. Oh, no, it won't be green. I forgot to change the inputs. So again, for input output, you have to change cin into whatever word you have here. In this case, I have fin, which is file input, and of course, file output as well. I forgot to do that. Okay, now let's try. If you want maximum efficiency while you're running the code, you can also make sure you haven't forgotten anything. You can kind of debug it a little. Oh, let's see. Um, huh. That is interesting. That's very strange. Ah, okay. I think I see the problem. So I believe the problem is in this white space over here. Aha, yeah, they do not have any white space after their last number, so that's pretty easy to fix. All we have to do is we don't print to n, instead we print n minus 1, and then we print n by itself. So what this does is basically it starts at n minus 1 and then prints n. So if you notice the difference is that this white space no longer happens after we print n. And yeah, that should work. Let me edit that here. F out array of n. Again, change this one to n minus 1. And now we submit. So again, it's normal that you'll have to debug your code. And you have to learn how to go through your code quickly and know where the mistake is. So generally sometimes, I guess there's a pretty frequent problem where your answer looks exactly the same as sample, but it marks as wrong. Memory limit exceeded. Okay, but yeah, what I'm saying is it's normal whenever that happens where your output is the same as answer, but they tell you it's wrong. It's generally a problem with the white space. So now let's see what's happening here. Runtime error or memory limit. Okay. Usually that means it's out of bounds, or let's look for the mistake. Okay, 0 to 1,000. That's right. Okay, reset frequency. And here we may as well reset array of I as well to 0. J equals 0. Okay, so we go through J to n. Yep. Aha. Is this there? Aha. So sometimes array j will result in a value that's not from 0 to 1,000. So basically what we can do is if array j is greater than n, or array j is less than 1. If that happens, we break out of the loop, and then we check. Obviously some will be empty, so once we break out of this loop, this will always break as well. Because this, obviously, if we stop early, one of the numbers, at least one of the numbers, will be missing. So that way, the error, like I said, once you see this, our program is not very slow. Okay, not stop-time limit, but runtime error or memory limit. Our memory is not that big. We only have a few arrays of size 1,000, right? Even a million would work, so it shouldn't be a memory problem. So then the next thing you want to think of when using arrays, the next likely problem is out of bounds. So now I look through where could it possibly be out of bounds. J goes from 0 to 1 to n, can't be out of bounds. So now I see this. This is likely to be out of bounds. And the reason for that is when the array doesn't work, the example array doesn't work, so uh, this doesn't satisfy every single number here. It's possible that it will create a number that's not even in the range, so like negative number that's below 1 or greater than n. Right, so when this happens, obviously this will lead to an error because the frequency array only goes from 0 to 1,000. And when it does happen, all you have to do is break. You just stop it early. You don't even fill in the array. Obviously, if you don't fill in the array, the frequency list also won't be filled, and therefore it'll break over here as well. And then you just go into the next loop. Yeah, this should work. Change all the input stuff as well. Right here, and now let's try again. Okay. Yeah, so here I was able to debug it relatively quickly. Sometimes you'll just have to go through like line by line and look for, oh, right, I found this one. Okay, so yeah, sometimes you'll just have to go line by line and look for the error. But in this case, I was able to determine like the likely possible error and find it pretty quickly. But yeah. Okay. Alright, first two work. And yeah, there we go. We got all 10. And now I will review the solution to the problem very quickly. So the solution for this, basically, we use the B array. So we first determined that with the B array, if we ever have the first term, we can determine the whole array by doing B1 minus the first term to determine the second term, B2 minus the second term to determine the third term, and so on, all the way to n. Or Bn minus 1 minus n minus 1, n minus 1, n minus first, n minus 1 term to get the nth term, right? And once we do that, we just check whether that array contains every single cal from 1 to n. If it does, then we print out the output. If it doesn't, then we continue on to the next possible first value. Yeah, so basically we check these first values from 1 to 1,000 to make sure that it's lexicographically the minimum. And whenever we find one that works, the first time we find it, we just print it and we end the program. So yeah, here's my code that does that again really quickly. Here's the input. I'm taking an input here as well. Input, all input into the B array. Now this is an important part. So basically I represents the first term that we're testing. So I represents A1, right? And now we loop through. I reset all of the arrays just in case. It might not be necessary since we're setting them up anyways, but I'm doing it just to be safe. Okay. And now here. So the first term we know is equal to, obviously, I, because, well, that's what we define I as. And this frequency array increases the frequency of I by 1 because, again, obviously, I appeared once. It's the first term. We just set it equal to that. And afterwards, this basically creates the array based on the first value I. So again, like I said, the J term will be equal to B of J minus 1 minus the previous term in the array. So again, let's say J equals 2, which means the second term in this array, which is this one, right? This one is equal to, again, 2 minus 1, or B of 2 minus 1 minus A of 2 minus 1. Again, so this is the third term, right? It would be B of 3 minus 1, which is 2 here, right? B2. And then you're subtracting A of, again, 3 minus 1, which is A of 2, which happens to be this term as well. So that's what this line does. So each term in the array is equal to B of J minus 1 minus the previous term in that array. And now, sometimes when this doesn't work, so let's say the first term is not I, right? So this I value over here does not work for this array. When that happens, sometimes the value you get will be below 0, it will be negative, it might be greater than 1,000 or greater than n. So when that happens, your frequency array might be out of bounds. Since that's the case, what you do is, if that happens, you just you get out of the loop before you can check the frequency array, and that will avoid any out of bounds errors. Finally, after this part, you've basically created the array, the array called, oops, the array called A, and after you've done that, you just loop through the frequency array, check whether every number is present. If any number has frequency of 0, that means it's not present, and not all the cows are in the picture. And otherwise, by the time j equals n, you've checked all the cows, all of them are there, and now all you have to do is just print the output, and yeah, that's all. One minor detail, of course, is after the last term, you don't want to print out a white space, so you print out to the second to last term, and then you print out the last term by itself without the space. And yeah, that's all for the solution.